Overview and definition of digital town. The digital town is a city connected to the net, equipped with technological platforms for information and communications management. These platforms make it possible to process huge amounts of data and information to offer new services to the inhabitants of urban areas and new functionality for the management of the urban environment. It is a town that incorporates information and communication technologies to enhance the quality and performance of urban services such as energy, transportation, and utilities to reduce resource consumption, wastage, and overall costs. Digitalization also encourages the introduction of new safety and renewable source technologies. Components of a digital town. Smart infrastructure. Smart buildings and properties. Smart manufacturing. Smart city services. Smart energy management. Smart water management. Smart infrastructure. Smart city initiatives have gained momentum in cities around the world. Smart city infrastructure is enabling efficiency, cost reduction, and improved living for city occupants. Smart infrastructure helps to increase understanding and the control of operations and optimize the use of limited resources in a city. One of the key value propositions of information and communications technology in a smart city is the ability to capture and share information on time. Smart infrastructures comprise several operators from different domains of activity, such as energy, public transport, public safety. Smart lighting. Smart urban lighting will adjust the intensity of the light depending on the people who are around. Smart street lights can be made intelligent by placing cameras or other sensors on them, which enables them to detect movement. Additional technology enables the street lights to communicate with one another. For example, the sensors that can detect when a person enters a room, the lights turn on and lights turn off automatically when he goes out. Smart parking. Smart parking is a parking strategy that combines technology and human innovation to use as few resources as possible, such as fuel, time, and space, to achieve faster, easier, and denser parking of vehicles for the majority of the time they remain idle. There will be systems that will alert drivers when there is a free parking spot. Citizens will no longer waste their time looking for a place to park, and the city will be less polluted. For example, the French information of technology startup utilizes sensors placed on parking lots to detect whether space is occupied and then transmits the data to the application via low-power wide area network technology. Smart mobility. Smart mobility is best described as approaches that reduce congestion and foster faster, greener, and cheaper transportation options. Most smart mobility systems use data collected from a variety of sources about mobility patterns to help holistically optimize traffic conditions. Smart mobility systems include mass transit systems as well as individual mobility systems that feature bicycle sharing, ride sharing, vehicle sharing, and, more recently, on-demand transportation. That's all for the topic of smart infrastructure. Now we will be moving on to the next topic, which is smart buildings and properties. Smart buildings and properties. A smart building integrates the different physical systems present in an intelligent way to ensure that all the systems act together in an optimized and efficient manner. It is a structure that uses automated processes to automatically control the building's operations, including heating, ventilation, air conditioning, lighting, security, and other systems. A smart building uses sensors, actuators, and microchips. It makes occupant security and quality of life top priorities. Safety and security systems. These include implementing remote monitoring, biometrics, IP surveillance cameras, and wireless alarms to reduce unauthorized access to buildings and chances of theft. It also includes utilizing perimeter access control to stop access to restricted areas of the property and protect people in non-authorized areas. For example, a system of CCTV surveillance with high-definition cameras installed across the city to protect physical infrastructure, road, rail and waterways network. Smart meters. A smart meter is an electronic device that records consumption of electric energy and communicates the information to the electricity supplier for monitoring and billing. It is a type of gas and electricity meter that can digitally send meter readings to your energy supplier for more accurate energy bills. Smart meters come with in-home displays so you can better understand your energy usage. It typically records energy hourly or more frequently, and report at least daily. For example, Europe uses smart meters which can reduce load, disconnect, reconnect remotely, and interface to gas and water meters. Smart heating and ventilation. Smart heating and ventilation systems monitor various parameters such as temperature, pressure, vibration, the humidity of the buildings and properties such as movie theaters and historical monuments. Wireless sensor network deployment is the key to ensuring appropriate heating and ventilation. These sensors also collect data to optimize the HVAC systems, improving their efficiency and performance in the buildings. For example, remote control of the building's heating and air conditioning systems through an internet-controlled thermostat. That's all for the topic of smart buildings and properties. Now we will be moving on to the next topic, which is smart manufacturing. Smart manufacturing. Smart manufacturing is a broad category of manufacturing that employs computer-integrated manufacturing, high levels of adaptability and rapid design changes, digital information technology, and more flexible technical workforce training. The goal of smart manufacturing is to identify opportunities for automating operations and use data analytics to improve manufacturing performance. Smart manufacturing becomes more common and more machines become networked through the Internet of Things. They will be better able to communicate with each other, potentially supporting greater levels of automation. Smart factory. A smart factory is a highly digitized and connected production facility that relies on smart manufacturing. A smart factory works by employing technology such as artificial intelligence, robotics, analytics, big data and the Internet of Things, and can run largely autonomously with the ability to self-correct. Robots are expected to populate smart factories for routine work, working alongside people. For example, smart factories within logistics technology are driverless transport vehicles. A technology that is becoming increasingly important. Unlike assembly lines, they can transport components flexibly from station to station without having to follow a specific sequence. Blockchain. Blockchain technologies have the potential to radically change the face of manufacturing. Blockchain, most commonly associated with cryptocurrencies such as Bitcoin, is a digital ledger technology that can be used to store and record transactions. The chains are stored and distributed across nodes in the network. It is very difficult to falsify records. The technology is believed to be more secure and faster by enthusiasts and is being tested for many industries. Condition monitoring and control. Condition monitoring is a valuable resource for researchers in manufacturing and control engineering, as well as practicing engineers in industries from automotive to packaging manufacturing. It is the process of monitoring a parameter of condition in machinery, to identify a significant change which is indicative of a developing fault. It is a major component of predictive maintenance. It allows maintenance to be scheduled, or other actions to be taken to prevent consequential damages and avoid its consequences. For example, troubled assets monitor critical assets that are already on watch and might not make it to the next scheduled downtime. Identify further progression before it leads to catastrophic failure or downtime. That's all for the topic of smart manufacturing. Now we will be moving on to the next topic, which is smart city services. Smart city services. Smart city technology allows city officials to interact directly with both community and city infrastructure and to monitor what is happening in the city and how the city is evolving. It may be more prepared to respond to challenges than one with a simple transactional relationship with its citizens. It is a designation given to a city that incorporates information and communication technologies to enhance the quality and performance of urban services such as energy, transportation, and utilities to reduce resource consumption, wastage, and overall costs. Automatic healthcare dispatch. Health services consist of medical professionals, organizations, and ancillary healthcare workers who provide medical care to those in need. Health services serve patients, families, communities, and populations. Smart healthcare devices can be implemented in public places to provide 24/7 healthcare for patients, like dispensing medicines and drugs to patients. These devices can also be used to call an ambulance to pick up the patients in cases of emergencies. For example, the patients who used this smart monitoring system, known as PsyCore, experienced less severe symptoms related to both the cancer and its treatment when compared to a control group of patients who carried on with regular weekly physician visits. Fire, explosion management. Smart fire sensors can detect and automatically take actions based on the level of severity, such as detecting false alarms, informing firefighters and ambulance, blocking off nearby streets, buildings on the requirement, helping people to evacuate, and coordinating rescue drones and robots. For examples, fire safety involves many disciplines from detection, alarming, evacuation and extinguishing to danger and building management. If all of them are carefully geared to each other, then you can be assured that your employees, visitors, guests, and assets are maximally protected. Smart waste management. Smart waste management includes the monitoring, collection, transport, processing, recycling and disposal of waste. It reduces waste and categorizes the type of waste at the source and develop methods for the proper handling of waste. Not all places generate the same kind or the same amount of waste. With smart containers and a good fleet management system, the routes can be tailored to any situation. The improvement of the urban waste collection service and, in general, the achievement of more efficient management of the waste, is one of the main challenges that the cities face, especially due to the population growth. For example, smart bins are adopted by Nambourshire Council in Australia that led to great results over the past years. They installed the Big Belly Smart Bin of world-leading company Big Belly Incorporated from Needham, MA in the United States that specializes in smart waste and recycling solutions for smart cities. That's all for the topic of smart city services. Now we will be moving on to the next topic, which is smart energy management. Smart energy management. A smart energy system is a cost-effective, sustainable and secure energy system in which renewable energy production, infrastructures, and consumption are integrated and coordinated through energy services, active users and enabling technologies. Objectives of these are resource conservation, climate protection, and cost savings, while the users have permanent access to the energy they need. Energy management systems can also be used to control refrigeration equipment, industrial processes, or other systems. Smart grids. A smart grid is an electrical grid that includes a variety of operation and energy measures including smart meters, smart appliances, renewable energy resources, and energy-efficient resources. They will provide the necessary amount of electricity depending on the demand. This way the power efficiency will be maximized. For example, distributed generation sources are used to reduce the cost of transmission and distribution. It includes solar, wind, biomass and fuel cells which are closer to the end users. Distributed energy resources. Distributed energy resources is a small-scale power generation sources located close to where electricity is used. It provides an alternative to or an enhancement of the traditional electric power grid. It is a faster, less expensive option for the construction of large, central power plants and high-voltage transmission lines. It offers consumers the potential for lower cost, higher service reliability, high power quality, increased energy efficiency, and energy independence. Smart homes. Homeowners have found ways to help lower their utility bills and conserve electricity. There is the installation of home appliances that are energy-saving like dishwashers, washing machines, dryers, and air conditioners. They also install better insulation in their walls, double-paned windows and energy-saving window coverings that enhance their control over the temperature in their homes. That's all for the topic of smart energy management. Now we will be moving on to the next topic, which is smart water management. Smart water management. Water management is the management of water resources under set policies and regulations. Water, once an abundant natural resource, is becoming a more valuable commodity due to droughts and overuse. Smart water management is essentially a system designed to gather meaningful and actionable data on the flow, pressure, and distribution of a city's water. Its main goal is to ensure that the infrastructure and energy used to transport water are managed effectively. Potable water monitoring. Common chemical parameters include pH, nitrates and dissolved oxygen. Measuring O2 is an important gauge of water quality. Changes in dissolved oxygen levels indicate the presence of microorganisms from sewage, urban or agriculture runoff or discharge from factories. It also monitors the quality of tap water in the cities. Potential savings. Incorporating intelligent water technologies allows water providers to find leaks quickly, with operators able to make better and faster decisions. A 30% energy saving and a 15% water saving can often be the result. Technology offers us the opportunity to build smart cities that can deliver that efficiency. Developments like the IUX application for intelligent water can help ensure that demand is met, quality is maintained while operating costs are minimized. Fish tank monitoring. Measuring the water conditions of aquatic animals such as snails, fish, crayfish, shrimps or prawns in tanks. Important values are pH, dissolved oxygen, ammonia, nitrite and water temperature. By Milwaukee pH controller we can monitor the pH level of the fish tank. That's all for the topic of smart water management. These are some of companies offering solutions and offerings for Digital Town. Accenture, Amazon, Google, Honeywell, IBM, Microsoft, Nokia, Nvidia. Thank you for watching this video presentation. Please continue to watch our other presentations to learn about technology industry. To follow us on social media, click on the link given in the description. If you like our video presentation and want more presentation on such IT topics, so don't forget to like, share and comment on our video. If you want firstly update of our new video, don't forget to subscribe our channel and press the bell icon.